In this video lesson, we will learn about trapezoids. So first, a quick reminder about what a trapezoid is. A trapezoid is a quadrilateral, so a four-sided figure, that has exactly two parallel sides, and I've marked them here with little arrows. So specifically, we're going to learn about the area and the perimeters of trapezoids. The perimeter is easy. It's just the sum of the four side lengths. But the area is slightly more complicated. Each trapezoid has a height, and the height is a line that's perpendicular to both parallel bases. And the area of the trapezoid is 1/2 times that height times the sum of the two bases. Or another way to write this would be the area is equal to the height times the average of the bases, which I'm writing right now. So this is the same exact expression. We just shifted where our 1/2 is. And both of them mean the same thing, and both are the area of a trapezoid. So now let's apply this to a few problems. So the first problem, we're asked to find the area and the perimeter of trapezoid ABCD, which is labeled in the picture. So the perimeter is easy. We just got 5, 6, 4, and 9. We add them. 5 plus 6 plus 4 plus 9. We get, that's 11 plus 13, and that in sum is 24. So the perimeter is 24, and I'll rewrite this over here. All right, so now the question is with the area. So the first thing is we know what the two bases are. The first base is 9, and the second base is 6, because those are the two parallel sides. Now the question is, what is the height, or the line that runs perpendicular to both? And in fact, the height is actually just equal to 4, because any line running perpendicular to both the parallel bases will have the same length as segment CD, which is perpendicular to both bases. So we have 1/2 times 4 times, in parentheses, 6 plus 9. 1/2 times 4 is just 2. 6 plus 9 is 15. 2 times 15 is 30. So the area is 30. Area is 30, perimeter is 24. And that concludes this problem. All right, let's do another problem. So the area of trapezoid ABCD is 60, and we're asked to find x. So x is the length of the height. Now, if the area is equal to 60, then the formula tells us that that's equal to 1/2 times h times b1 plus b2. b1 plus b2 are right here. They're the parallel bases. And x is the height. So we can rewrite this as 1/2 times x times 18 plus 12. And then this simplifies. We get 1/2 times x times 30, which is 15x. And this whole thing, remember, is equal to 60. So our equation is 15x equals 60. So we just divide by 15 on both sides, and this simplifies, and we get x equals 4. And that's the final answer. So the height is 4. And moving on to the last example. Now we want to find the area and perimeter of trapezoid ABCD. And we know that its side lengths are 3, 13, 13, and 13. So the perimeter, once again, is just adding these up. 3 plus 13 plus 13 plus 13. And that's equal to 42. You can calculate that with a calculator or just in your head, it doesn't matter. So perimeter is 42. So now we got to work out the area. So once again, the area formula involves the two bases and the height. So those are the three things we need to know. It's 1/2 h times b1 plus b2 in parentheses. So we have our bases. The bases are just 3 and 13. And then we also, the height, we know where it is. I just drew it, but we don't know what it's equal to. So I'll substitute in what we know so far. We know that the bases are 3 and 13. We add those, that's 16. So 1/2 h times 16. And then this equals 8h. So now the question is, what is h? Once we find h, we can just plug it in and know the area. So for now, I'm going to record that the area is equal to 8h, just for memory. And now we're going to have to figure out what h is. So notice that I drew down h here, and it intersects in the bottom with a right angle. But we can also draw h here, because the lengths are the same. So these two right triangles are, in fact, the same. They're equal right triangles. And what this means is that the bottom line, AD, which has length 13, is separated into two equal portions on the edges, and the middle portion has length equal to 3. Why 3? Because the length of BC is 3, and the heights form a rectangle with the two bases. So I get 3 and then 2 equal portions on both sides of 3. And those equal portions, we actually just solve this out. If they're both of length x, then we have 2x plus 3 is 13. And then this solves to x equals 5. And as you can see, we have 5, 3, 5, adding up to 13. So we know that the length from A to the first height is 5. And we also know that this length is 13. And since it's a right angle, then we can use the Pythagorean Theorem to calculate the height. So now, the reason we could do this was because the two right triangles that we split our trapezoid into, those two right triangles on the edges are the same. That way we know that both of them have that extra leg of 5. So we apply the Pythagorean Theorem. For more details on that, you can look at my video lesson about the Pythagorean Theorem. But in any case, we can just solve for x, and we get that x, or the height, is equal to 12. So that tells us the height. And we know that the area is 8 times the height. So we multiply 8 times 12. And we get 96. And that concludes the problem. Well, thank you for watching this video lesson. I hope it helped.